Hello viewers! Welcome to Operations Research 1 tutorial video. I'm KJ.
I'm Elmer.
And I'm Zyra.
And we are here to show you how to solve linear programming problems through a graphical method. Let me give you a brief introduction. A linear programming problem involves constraints that contain inequalities. An inequality is denoted with familiar symbols: greater than, less than, greater than or equals to, and less than or equals to. Due to these difficulties with strict inequalities, we will focus on greater than or equals to and less than or equals to. In order to have linear programming problem, we must have inequality constraints and an objective function, that is, a function whose value we either want to be as large as possible or as small as possible.
Personal Mini Warehouses is planning to expand its successful Orlando business into Tampa. In doing so, the company must determine how many storage rooms of each size to build. Its objective function and constraints follow. Maximize monthly earnings is equal to 50x1 plus 20x2, subject to first constraint 20x1 plus 40x2 lesser than or equal to 4,000, and this is for advertising budget available. Second constraint 100x1 plus 50x2 lesser than or equal to 8,000 for square footage required, and the third constraint x1 is lesser than or equal to 60 for rental limit expected, and x1 and x2 should be greater than or equal to 0, where x1 is the number of large spaces developed and x2 the number of small spaces developed. So the next thing we should do is to graph your constraints. So in getting the points in each constraint, you have to let your x1 and x2 be 0 to get the points. So for example, in the first constraint, 20x1 plus 40x2 lesser than or equal to 4,000. So let x1 be 0, so 20 times 0 plus 40x2 is equal to 4,000. So we have x2 is equal to 100. And let x2 0, 20x1 plus 40 times 0 is equal to 4,000. And you have here x1 is equal to 200. So your point here is 0, 100. And the next point is 200, 0. And you have to do the same process in your second constraint and third constraint. So this is now the graph of the three constraints in the problem, and as you can see, the corner points are labeled as to A, B, C, D, and E to easily find the values of your objective function. The shaded part of the graph represents the feasible region, which means the set of all possible points of an optimization problem that satisfy the problem's constraints. So an evaluation of the 5 corner points on the accompanying graph indicates that corner point C produces the greatest earnings, which has 60 large spaces developed and 40 small spaces developed with an earning of $3,800.
The Electricom Corporation manufactures two electrical products, air conditioners and large fans. The assembly process for each is similar in that both require a certain amount of wiring and drilling. Each air conditioner takes 3 hours of wiring and 2 hours of drilling. Each fan must go through 2 hours of wiring and 1 hour of drilling. During the next production period, 240 hours of wiring time are available and up to 140 hours of drilling time may be used. Each air conditioner sold yields a profit of $25, and each fan assembled may be sold for a $15 profit. Formulate and solve this LP production mix situation to find the best combination of air conditioners and fans that yields the highest profit. Use the corner point graphical approach.
So first is we will identify the unknown quantities. So these are x1 and x2. x1 is for air conditioners and x2 is for large fans. In the problem, it says that for air conditioners, it should have a 3 hours of wiring, then 2 hours for drilling. And for large fans, it should have 2 hours for wiring and 1 hour for drilling. And it also states that the two electrical products should have a profit in air conditioners of $25 and for large fans is $15. And the available time for wiring is only 240 hours and for drilling is 140 hours. After making a table, we can now make an objective function easily. So, since the problem states that we have to maximize profit, we use the word maximize. Z is equals to $25 x1 plus $15 x2. So, $25 means this is the profit for air conditioners and $15 for large fans. So, it is also subjected to from the two constraints. So, the first constraint is 3x1, which is 3 hours of wiring for air conditioners plus 2x2, in which there are 2 hours of wiring for large fans, must be less than or equal to available time, which is the 240 hours. Same goes with the second constraint, which is the 2x1 plus 1x2 less than or equal to 140, and xi must be less than or equal to 0.
After formulating the objective function, we should graph the two constraints in order for us to know which of them gives us the highest profit.
In order to know the objective function value of the graph, we should identify first all the corner points of the graph. So, in corner point A, we have values for x1 and x2, which is 0 and 0. And for corner point B, x1 is 70 and x2 is 0. For corner point C, we have x1 is 40 and x2 is 60. And for corner point D, we have 0 and 120. Next is we should solve for objective function value. So in solving for objective function value, we just substitute the values of x1 and x2 to the z formula. So in corner point A, we get B $0, we get $0. For corner point B, we obtain $1,750, and for corner point C, we obtain $1,900, and for corner point D, we obtain $1,800. Since the problem states that we should yield the highest profit, and out of all the corner points here, the corner point C yields the highest profit, which has a $1,900. In order for us to get $1,900 profit, we should have 40 units of air conditioners and 60 units for large fans.
Thank you for watching our video.
You can leave some questions and clarifications under the comment section below.
Please like and share this video.
And don't forget to subscribe.
Bye, viewers!